We always hear the equivalent circuit of a transformer. So, what is that equivalent circuit of a transformer? The equivalent circuit of a transformer, it consists of an ideal transformer connected externally to the winding resistance, reactance, conduct on what? On the load current. So, let's draw the equivalent circuit of what? Of a transformer. And we have a load here. We have the VZ. We have the VZ. And this is what, this is the number of turns. This is the primary number of turns. And here's the secondary number of what? Number of turns. And here is also what? The I1. And here's the V1. Here is the induce for primary and what? Primary and secondary. So above is the diagram of the illustration of an equivalent what? Equivalent transformer. From the definition of what? Of transformer, I explained that the equivalent of circuit of a transformer, what? It consists of an ideal transformer connected extremely to the reactance and what? Reactance and what? And the impedance and what? And the resistance. So we have to draw what? An equivalent circuit of primary and what? And secondary. So let's say we have. So as you can see, this is what? This is the ideal transformer, the primary and what? The primary circuit and the secondary circuit, the transformer. So this we have what? We have the IW, and therefore we have what? We have the R0, and also we have what? We have the I mu or I double or IM, which is this is a magnetizing current, and this is what? And this is a working current, and we have what? We have I naught here. The I naught, the component of I naught, which are what? IW and what? And I mu, which is the working current and the magnetizing current, and we have what? We have X naught here, and also we have the current that is flowing down to this circuit, and we have what? We have R1, and also we have X1, and we have Z what? Z1 here. So therefore we have the primary voltage, we have the secondary voltage, and we have what? We have R2, and therefore we have what? We have X2. Also at here, at this point, we have what? We have the impedance. So after then I have the induce here. I have something like this. So this is what? This is a primary circuit. The equivalent of what? This is an ideal transformer. This is the equivalent circuit of a transformer, but this is an ideal transformer which is connected extremely with what? With the reactance, resistance, and what? And the impedance. So this is what? This is a primary circuit, and this is a secondary circuit. So this is a secondary circuit. And then what next? I have to say I have I1 here, and I have what? And I have I2 here. So from this I have to relate some formulas. I need to have some formulas here. So we have what? If you take a look to this, we have R0. So therefore this R0 is the same thing as what? E1 divided by what? RW. So therefore we have what? R0, which is equals to E1 divided by what? I magnetizing. And also X0. X0 is the same thing as what? As E1 divided by what? Divided by what? Divided by I mu. And the Z1, we have Z1, we have Z2. So Z1 should now be equals to, which is what? Which is R1. Z1 should now be equals to R1 plus what? Plus J what? Jx1. So this J, it is showing what? If we come to calculation, you might see that if we are going to solve this, we are going to take the magnitude. This Z is like what? It's like taking the magnitude of what? Of this. And also Z2 is the same thing as what? We have R2 plus what? Plus Jx what? Plus Jx2. And therefore we have what? We have E2 prime, which is the same thing as what? E2 by R. And also we have what? B2 prime, which is the same thing as B2 by what? B2 by R. And we have the I2 prime, which is the same thing by what? I2 multiplied by what? Multiplied by R. And also we have what? We have R2 what? R2 prime, which is the same thing as R2 by what? By R. We have X2 prime, which is the same thing as X2 by R. And also we have what? We have the impedance Z2 prime, which is the same thing as what? Which is the same thing as, which is the same thing as Z2 over what? Z2 over, yes, Z2 over R. This is R, which is the turn ratio. As you can see from this ideal transformer, the primary and secondary circuit, we figure out some formulas. So these formulas are very important in what? Consider to the primary and what? Secondary what? Primary circuit and what? Secondary circuit. So these formulas are very important in equivalent circuit of what? Primary and what? And secondary. So the next thing that we are going to see, we have to see the exact circuit, the exact equivalent circuit of a transformer, because this is not an exact circuit. This is primary circuit and what? Secondary circuit. So now we are going to see the exact circuit of the both primary and what? Both primary and the secondary what? Secondary circuit. So now the exact equivalent circuit will now be, we have the resistance. This is an exact equivalent circuit of a transformer. As you can see, we have what? This is R0. We have R0 here. The equivalent circuit, we have R0, and then we have X0, and we have the working current, and we have the magnetizing, which is I mu. Either you call it I mu or what? Or IM, which is the magnetizing current. And also we have what? We have R1. We have also we have R1 here, and we have X what? X1, and this is what? This is the Z1. And also we have R2, and we have what? We have X2, and in this part we have Z2. We have Z2. This is X2. This is R1. So also don't forget we have the current that is passing through. We have I1. And we have what? We have I2, and we have the current here, which is I0, and therefore we have what? We have the primary voltage, and therefore we have what? This is ZL, and therefore VZ is the same thing as what? It is the same thing as VZ is the same thing as VL, and from this point E2 prime is the same thing as what? Is the same thing as E1. Above is the exact equivalent circuit of a transformer. Circuit of a transformer. So from here you have to take note that this is the exact equivalent circuit of a transformer, but after then we have to what? We have to show, or we have to draw the equivalent circuit of secondary refers to primary parameters. So to do that is the same thing as what? Is the same thing as drawing this. We have to say only thing will change is this. It will now become the VL prime the same thing as what? VZ by what? BZ by R. So at this change, and also this load should now turn to what? L prime. So as you can see, here is the equivalent what? The equivalent circuit of X-former, let's say is the same thing as transformer, with what? With secondary parameters refers to primary. With what? with secondary parameters refers to what? Secondary parameters refers to primary parameters. Make sure you draw it. If we take a look to this circuit, have something ZC which is called what? Which is called the impedance what? Exciting what? Exciting cycle. So therefore the Z total should now be equal to Z1 plus what? Plus ZC, which is parallel to what? Parallel to this and this. So which is what? Which is Z2 plus what? Plus ZL prime. So this and this are in parallel. So the ZT should now be equals to Z1 plus this. This and this are in parallel. So I have to what? I have to multiply them and what? Divide it by addition. So therefore, according to this, according to the parallel resistance, which 1 over R total is equals to 1 over R1, 1 over R2 up to 1 over R of N. So this is the same thing as ZC multiplied by what? Z2 prime. I have prime here plus what? Plus ZL prime, all divided by what? ZC plus what? Plus Z2 prime plus what? Plus ZL what? Plus ZL prime. So the next formula that I want you to know is that we have the formula that says what? So take note of this. But this don't forget is for what? For exciting impedance. The Z total, which is for the what? For the exciting what? Exciting impedance. What I mean by that is that don't be confused. This impedance is what? Using the ZC. But if you are dealing with no load, this should not be the exciting, but it will be what? Z0, which is the no load what? Current considered to what? Considered to the impedance, because the Z0 is at no load current. That's why it becomes what? Z0. And we have Z2 prime, which is the same thing as what? Z2 prime, which is the same thing as R2 plus what? Plus J, which is what? Which is X what? Which is X2, and it has to be prime, all with prime. We have what? We have the R2 prime, and also we have what? We have the X2 prime, and also we have the Z prime L. And therefore this R0 prime, this is the same thing as what? As we did it before, R2 over what? R2 over R, and also which is what? X2 over R, which is also ZL over what? Over R. So all these formulas are very important. So, but in this case, this has to be what? With squared, all with what? All with squared.